We're going to learn about 4 types of lines that can be made within triangles or sometimes outside of triangles, depending on those lines. The first type of line we'll construct is called a perpendicular bisector. So we're going to write perpendicular bisector. What you're going to do first is construct the midpoint of each side of the triangle. And just as a heads up, this is going to look really messy. So don't be overwhelmed with the picture, just know what to expect. And to show that these are midpoints, you need to put tick marks on each side of the triangle. Just like that. Now, as best you can, I want you to draw a line coming out of the midpoint so that it makes a right angle with the midpoint. And to show that, I'll do this. I'll use dashed lines. So that looks about 90 degrees. So we are going to have to eyeball it a little bit here. We'll do the same thing. And go ahead and mark those 90 degrees. So you're looking for 3 sets of tick marks, 3 boxes, got them, and then the point where they all intersect. I'm going to mark that with blue, or actually with purple, I think. So right here is where all 3 of those lines come together. That point is what we'll talk about on the other side. So let's go ahead and define perpendicular bisector. It is a line that splits a segment in half and makes a right angle. Those ones tend to give kids the hardest time, but perpendicular bisector, think of it as 2 words. So it should do 2 things. It both bisects or splits in half, and it's perpendicular or makes a right angle. And there are 3 of them in every triangle. Next line we're going to talk about is a median, and this one's going to be pretty easy. A median connects a vertex to a midpoint. So go ahead on your triangle and make the midpoint, and you'll have to eyeball it, do the best you can. Make the midpoint of each side of the triangle and then put in tick marks to show that. And then you're going to connect each vertex, and I'll use a different color for my lines here. We're going to connect each vertex to its opposite point, or the midpoint. And we're going to do that for every vertex. And if you do it correctly, they should all come together at a point. So we call all three of those lines medians. The next type of line is called an altitude. An altitude comes from a vertex. And makes a right angle. So for example, if this is a vertex, you simply draw a line that makes a right angle with the opposite side. So we call that an altitude. Now, I'm not going to draw all three altitudes because it would make the picture very confusing, so we'll just use one for now. I do want to point out the difference between altitude and perpendicular bisector. An altitude does not need to split a side in half, but an altitude must touch a vertex, whereas perpendicular bisectors do not need to touch a vertex. As long as they split in half and make 90 degrees, that's all they need to do. So that's the difference. They both have a 90 degree, but there's no midpoint with an altitude. And there's no vertice necessarily with a perpendicular bisector. There could be, based on some triangles, but there does not have to be a vertex that it goes through. And then the last line, we've heard of this before, is an angle bisector. And it's simply a line that splits an angle in half. So we go ahead and draw. You have to look at the angle and figure out what's the halfway point. Let's about there. I don't care where the line ends up. I care about splitting the angle in half. And to show that, we draw those little rainbows. So each of these angles has one rainbow. That means it's split in half. Then we're going to do that 2 more times. So try to split the angle in half as best you can. And this time we'll put 2 little rainbows in there. And then the third time, again, we're going to split in half. And if you do it right, they should all come together at one point. So you need to show the rainbows. It needs to look about right. And that's really it for an angle bisector. So we need to know how to draw these pictures. We need to know how to recognize them. And we need to remember these 4 words: median, perpendicular bisector, altitude, angle bisector. And that will take some practice. This side is, you should have gotten these 4 triangles on a separate sheet of paper. Go ahead and cut those out and paste them into the spots like I have. And then we'll talk about what each name of each point is and its properties. So go ahead and pause the video, and when you're ready, you can restart it again. I want to start by defining point of concurrency. And all it is to be a point of concurrency is 3 lines just need to intersect. The point where they intersect is called a point of concurrency. Now we talked about four special lines in triangles: medians, altitudes, perpendicular bisectors, and angle bisectors. But we're actually going to talk about where those special lines come together, and those points have a special name. So in the first one, we want to identify the types of lines that we see in the picture. And if I look here, each side is bisected, split in half, and these lines are perpendicular. So these are perpendicular bisectors. And what they do is they make a circumcenter. And let's call this point K. So that means that in this picture, point K is a circumcenter. So that's our first vocab word for concurrency. Perpendicular bisectors go with circumcenter. We just want to make that relationship. We want to match those together. Now there's special rules with the circumcenter. And those rules are the following. From K to C, K to A, and K to B, they are all the same distance. So you can make a triangle or a circle that the triangle fits perfectly in, meaning all its vertices are on the circle. And we know that all three of these distances are the same. That's rule number one. In the second figure, these are all angle bisectors. And where they come together at point I, we call an incenter. So that's another one we need to remember. Angle bisectors make an incenter. Really no specific rules with an incenter that we need to know in this class. There are certain rules, but we won't be learning them in this class. But I do want to point out that an incenter basically says that you can make a circle that fits perfectly in the triangle. So we say that this circle is inscribed in the triangle. Whereas this circle is circumscribed about the triangle. Circumscribed about just means it's drawn outside perfectly. Inscribed in means it's drawn inside perfectly, meaning nothing comes, like all the vertices fit on the circle and all the sides of the circle fit within the triangle. These are all medians, and together they will make a centroid. So centroid is our new word. And that point is going to be right here. Now there is a special rule with centroids. I've already put numbers in so you can see them. You will always have a smaller and a bigger side. The smaller side will always be half of the bigger, always. So we'll say that the sides of a centroid have a 2-to-1 ratio. And what that means is one side is twice the length of the other side. And the last one. These lines are all altitudes. And together they make an orthocenter. Special rules with an orthocenter, you just have to know what an orthocenter is. It's where all the altitudes come together, which is right here. So all three of these altitudes intersect at point H, which is the orthocenter.